So as an addendum to the Regen X motor video, when we consider the conventional motor, the yellow universal motor, when we consider the power calculations for the traditional motor, we have input power that is being converted to output power, and the output power is the mechanical power in the drive shaft, which is the torque times the angular velocity. Now, when we consider the Regen X motor, the power calculations become a little bit more detailed. And so when we look at electric motor power calculations, electric motor output power is traditionally a measure of the mechanical output power, which is torque times angular velocity. In the case of the Regen X motor, we also have to consider the motor coil's recovered magnetic field energy in concert with the generated electric energy. Stored electromagnetic field energy in standard motor rotor stator arrangements in conventional motors is generally wasted as heat and light when the alternating magnetic fields are deliberately and uneloquently collapsed and reversed as rapidly as possible. In the case of the brushed universal motor, the sparking on the commutator is due to the design of the motor, whereby the used motor magnetic fields are shorted out and dissipated as quickly as possible to allow for the alternating magnetic field, which allows the motor to operate. So, however, when we consider the Regen X motor, the coil design, timing, and redirection circuit of the Regen X motor is able to recover this otherwise unused and eminently useful energy in the form of magnetic field energy. Electric motors are plagued by losses associated with generator action in a motor, which is manifested as armature reaction, motor neutral plane shift, and flux weakening. Shorted magnetic field energy in brush motors leads to sparking, heat buildup, and brush wear, brush pitting, and reduced brush life. The Regen X motor addresses the problems associated with generator action in a motor by encouraging the Regen X motor to simultaneously and naturally operate as a generator when the motor cycle has been completed. Generator action in a motor happens whether we want it to or not, and it may be useful to take advantage of generator action in a motor. So when considering the Regen X motor, P out, the simple formula of torque times speed needs to be more inclusive, as Regen X motor power out is the torque times velocity plus the power that's recovered from the collapsing magnetic field energy plus the power that is generated when the Regen X motor cycle stops and the generator cycle begins. Thus, the efficiency formula for the Regen X motor must be inclusive of all three forms of energy present, i.e. mechanical drive shaft output power, plus the motor coil electromagnetic field power in the recovery mode, and generator coil power in the generator mode.